Good morning children. This class we will discuss about periodic classification 2. In the previous class we have learned that periodic table is a chart of elements and the elements have been arranged in the increasing order of their atomic numbers. The modern periodic table states it is a tabular column. Periodic table is a tabular column which highlighting the regular properties of the elements. Okay. Periodic table is a tabular arrangement of elements. Okay. Arranged in rows and columns highlighting the properties of the elements. Right. So the modern periodic table states it is nothing but a tabular column which is arranged in rows and columns highlighting the properties of the elements. Okay, periodic table is a tabular arrangement of elements. That one you have to remember, right? Okay, and in the periodic table the elements are arranged into groups as well as in periods. So what are called periods? What are called groups? If you take periods, the horizontal rows are called periods. Okay. So these are the horizontal rows. So the horizontal rows are called periods and there are 7 periods in the periodic table. This is the first period, second period, third period, fourth period, fifth one, sixth, seventh. So, periods means the horizontal rows are called periods and there are 7 periods in the periodic table. Then what about groups? Groups means the periodic table, the elements are arranged in vertical column starting from top to bottom. Okay, these are the vertical columns. The elements are arranged in vertical columns starting from top to bottom are called groups and there are 18 groups in the periodic table. This is the first group, second, third, fourth, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. So there are 18 groups in the periodic table. This also you have to remember. Next thing, based on the common characteristics the elements can be arranged into various groups. Okay. So, see, look at this tabular column. Group number as well as its family is given. If you take the first group elements are called alkali metal family. Okay. First group elements are called alkali metal family. So this is the first group. So these elements are called alkali metal family. Next one, group number 2 are called alkali earth. All the elements which is present in group number 2 will come under alkali earth metals. Okay. So this is the group 2. Here all the elements beryllium, magnesium, calcium, strontium, barium, radium, all these elements will come under alkali earth metals. Okay. Both alkali metals and alkali earth metals are highly reactive elements. Right. Next one, group number 3 to 12. Group number 3 to 12 will come under transition metals. So this is the group 3, this is the group 12. So all these elements will come under transition metals. Okay, these are all transition metals. Transition metals means here it is half filled. When you come for the next level, you will learn about the transition metals in details. Okay, it is partially filled, it is not fully filled. Right. So next one is group number 13. Group 13, where is group 13? This is group 13. Group 13 is called boron family. See, in group 13, boron, aluminium, gallium, indium, thallium. These elements are given. But boron is the head of this family, right? So group 13 is called boron family. Next, group 14. Group 14 is called the carbon family. This is the group 14. Here carbon, silicon, germanium, tin, lead is given. Carbon is the head. So carbon family. Group 14 is called carbon family, right? Next one, carbon 15. Carbon 15 is nitrogen family. So this is group number 15. Nitrogen, phosphorus, arsenic, stannous, bismuth is given. Nitrogen is the head of the family because the first element is nitrogen in group number 15. Next, group number 16 is oxygen or chalcogen family. This is group number 16. Oxygen, sulfur, selenium, tellurium, polonium is given. So this family is called oxygen family because oxygen is the head of this group number 16 family. Also, this family is otherwise called as chalcogen family. Chalcogen is actually a Greek word, and the meaning for this chalcogen is ore producer. Okay, so all these elements will produce ores. That is what they are saying, chalcogen family. So next one, group 17 is called halogen family. These are group number 17. Fluorine, chlorine, bromine, iodine. These elements will come under halogens. Okay. Next one, group 18 or noble gas family. Group 18 is helium, neon, argon, krypton, xenon, radon. These elements will come under group 18, and the head of this family is called, it's not a head, actually this group family is called noble gas family. Group number 18 is called noble gas family. Among them, helium is the first element, right? And these helium, neon, argon, krypton, xenon, these noble gases will not react with other elements. Okay, that is what we are saying. It is called noble gas family, right? So based on the common characteristics, elements can be segregated into various families. Okay. Next, we can take elements can be classified into metals, non-metals, and metalloids. Metals means the elements which contains one or less than 3 electrons which is present in the outermost shell of an atom. Then we can say it will come under metals. Okay, those elements will be considered as metals. For example, aluminium, iron, copper, gold, silver, all these things will come under metals. Whereas non-metals means the elements which contains 5 or more electrons which is present in the outermost shell of an atom of the element is known as non-metals. All the gases will come under non-metals. For example, hydrogen, oxygen, nitrogen, sulfur, carbon. These elements will come under non-metals. Okay. Then what do you mean by metalloids? Metalloids means elements which exhibit both the metallic character as well as non-metallic character, intermediate between the two. Okay. So those elements are called metalloids. It will have the metallic character and as well as non-metallic character. Those elements are called metalloids, and they will come under semiconductors. Okay. For example, boron, silicon, germanium will come under metalloids, right? So first you should know about the modern periodic table. It is nothing but a tabular arrangement of elements in rows and columns, highlighting the properties of the elements. Next one, you should know about what are called periods. How many periods are there? The horizontal rows are called periods, and there are 7 periods in the periodic table. And groups means the vertical column starting from top to bottom. Okay, those are called groups, and there are 18 groups starting from here to here. 18 groups are present in the periodic table. Next you should know about what do you mean by metals, non-metals and metalloids. Also you should learn about the various families. Okay. Shall we move to the next one? Right. So next we can go to periodic properties. What do you mean by periodic? Anything which repeats itself after a regular interval are called periodic, and this behavior is known as periodicity, right? Properties such as atomic radius, ionic radius, covalent radius and ionization energy, electron affinity, electronegativity, these will come under regular periodicity, hence they are called periodic properties. Okay. Before we enter into this periodic properties, first we should know about what is meant by valency. Okay, what do you mean by valency? Valency is nothing but the combining capacity of an element, right? The combining capacity of an element is called valency. For example, you can take ammonia compound. The formula of ammonia compound is NH3. Nitrogen reacts with the hydrogen to form the compound ammonia, right? Compound means what? Combination of two or more different elements. That is called compound, isn't it? Nitrogen is a compound, nitrogen is a separate element, hydrogen is a separate element. Both the elements combine to form the compound ammonia. Here, one nitrogen atom reacts with three hydrogen atoms to form the compound ammonia. Then what is the valency of nitrogen? The valency of nitrogen is 3. Why? Just now I told you, valency means the combining capacity of an element with respect to hydrogen. Okay, the combining capacity of element is called valency. So the valency of nitrogen is 3 because it combines with the 3 atoms of hydrogen. Got it? So what do you mean by valency? Valency means the combining capacity of an element. This is called valency, right? Okay. So next one, how is valency of an element determined? Okay. The valency of an element is determined by its valence electrons. Okay. The valency of an element can be determined by its valence electrons. We know very well electrons are negatively charged particle and it revolves around the nucleus. Okay. An atom is electrically neutral because the positive charge of nucleus is equal to the negative charge of electrons, right? So, how is valency of an element determined? The valency of an element determined by its valence electrons. That point you have to remember, right? Good. So next one, what are valence electrons? What do you mean by valence electrons? Electrons you know, right? It is a negatively charged particle. It revolves around the nucleus. That is called electron. What do you mean by valence electrons? In an element, the electrons which is present in the outermost shell of an atom. Okay, the electrons which is present in the outermost shell of an atom are called the valence electrons. Okay, that point you have to remember. In an atom, the element which the electron which is present in the outermost shell of an atom is called the valence electrons. Okay. For example, we can take the helium atom. Okay. You take the helium atom. So this is helium atom. This is the first shell. Okay. First shell is called K shell. Isn't it? First shell is K shell. Second shell is L shell. Third shell is M shell. Fourth shell is N shell. And it will go on like this. Right. So, in the first shell, 2 electrons are present. Okay. For this helium atom, this shell is the outermost shell. Okay. For this helium atom, this shell is the outermost shell. So, how many 2. 2 electrons are present in the helium atom, isn't it? For this helium atom, this is the outermost shell and it is also called K shell, right? So 2 electrons are present. These 2 electrons are called the valence electrons. Why? Because these electrons are present in the outermost shell of an atom. Understood? Right? Shall we move to the next one? Good. So next we can move to lithium atom. Okay. So this is the lithium atom. If you see the lithium atom, it has 2 shells. Okay. This is the K shell, that is first shell, and this is the L shell, that is second shell. Okay. In the K shell, how many electrons are present? 2 electrons are present. Okay. In the first shell, how many electrons are present? 2 electrons. And in the second shell, that is in the outermost shell, how many electrons are present? Only 1 electron is present, isn't it? So what is the how many valence electrons are present in lithium atom? The number of valence electrons which is present in the lithium atom is 1, because in the outermost orbit 1 electron is present, isn't it? So what do you mean by valence electrons? Valence electrons means the electrons which is present at the outermost shell of an atom is called the valence electrons. Got it? Right. Next we can move to why are valence electrons important? Valence electrons are important because these electrons takes part in the chemical reaction. Okay. So valence electrons are important because these electrons directly take part in the chemical reaction. Right. And also here you should know about the octet rule. You should know about octet rule. Octet rule means actually in an atom the outermost shell contains only 8 electrons. If more than 8 electrons are present, the remaining electrons will go to the next shell. Okay, only you can accommodate 8 electrons in the outermost shell. If more than 8 electrons are present, then the remaining electrons will go to the next shell. This is called the octet rule, right? Okay. So why are valence electrons important? Valence electrons are important because these electrons are take part in the chemical reactions. Got it? Right. Next. How do we determine the valency of an atom? Okay, how do we determine the valency of an atom? So, valency of an atom determines directly with the valence electrons only. Okay, if an atom contains 1, 2 or 3 electrons, it is very easier for them to lose that 1, 2 or 3 electrons to achieve the octet rule. Okay. At the same time, if an atom contains 5, 6 or 7 electrons, it is easier for them to gain 1, 2 or 3 electrons to achieve the octet. Okay. The same example we can take for this one. Determine of the valency of an atom. Okay, so these things you have to remember. For example, we can take oxygen atom. Okay, this one we can take as an example. This is the oxygen atom. Here, how many shells are there? Here, this is the first shell, second shell, and 2 shells are there. This is the interior part is called nucleus. Okay, this is the center part. This is the first shell and this is the second shell. In the first shell, how many electrons are present? 2 electrons. In the first shell, only we can accommodate 2 electrons. This one you have to keep it in your mind, right? And in the second shell, see, also this is the outermost shell of this oxygen atom. So in the outermost shell, how many electrons are present? 1, 2, 3, 4, 5, 6 electrons are present. In the first shell, 2 electrons are present. In the second shell, 6 electrons are present. Okay. So, it is very easy for this oxygen atom to Next we can move to nitrogen atom. For nitrogen atom also it has two shells. Okay, this is the first shell and this is the outermost shell. In the first shell, in K shell, 2 electrons are present, and in the outermost shell calculate 1, 2, 3, 4, 5. 5 electrons are present. Okay, in the first shell 2 electrons, second shell as well as in the outermost shell 5 electrons are present. So it is very easy for the nitrogen atom to gain how many electrons? 3 electrons to achieve octet. Okay. By keeping all these points in mind, you have to fill the electrons in for different elements. Okay, we have to follow the octet rule. Okay, right. Next we can move to atomic radius. Atomic radius is nothing but it is defined as the distance between the center of the nucleus to its outermost orbit. Okay. Distance between the center of the nucleus to its outermost orbit of an atom is called the atomic radius. Okay, so this is the nitrogen atom. So inside the nucleus, 7 neutrons as well as 7 protons are present. This is the center part of the nucleus. So the distance between the center of the nucleus to its outermost shell. This shell is the outermost shell for this nitrogen atom. So distance between the center of the nucleus to its outermost shell are called the atomic radius. Okay, and atomic radius is measured in picometer. In short, we say it is measured in pm. Pm is picometer. It has a value, that is 1 picometer is equal to 10 to the power minus 12 meter. It's a need-based question that also you have to remember. Okay. So what do you mean by atomic radius? Atomic radius is defined as the distance between the center of the nucleus to its outermost shell containing the valence electrons. This is called the atomic radius, right? Okay. Next we can move to variation of atomic radii in period as well as in group. Okay. So along the period from left to right, atomic radii decreases, whereas from top to bottom, okay, from top to bottom, atomic radii increases. What is the reason? Once again I will tell you. Along the period from left to right, atomic radii decreases. Okay. Why? Because here the shell number remains the same, but at the same time the number of protons increases. Number of protons is nothing but atomic number. Okay. The shell number remains the same, but the atomic number, that is number of protons, increases. So more and more positive charges make the strong attraction force over the electrons. Okay, it makes the strong attraction force over the electrons, and hence the electron clouds shrinks. That is why along the period from left to right, atomic radii decreases, whereas at the same time from group top to bottom, atomic radii increases. Why? Because here the shell number increases. As the shell number increases, the distance between the valence shell and the nucleus increases. That is why group wise atomic radius increases. Okay. So you have to keep all these points in mind, children. Next we can move to ionization potential energy. Those things we will discuss in the next video. In the meantime, what are the things we have learned today? Modern periodic table. Periods means what? Groups means what? And then periodic properties, and we saw about various families, periodic properties. Okay. And what do you mean by valency? How valency of an element